So now we're starting a new chapter and we're going to focus all about solving equations. Now I understand you've probably been solving equations ever since you've probably been in high school. This video in particular is going to focus on solving equations by graphing. Now I would say to you that if you struggle with the algebraic way of solving equations, as you're going to see in later videos in this chapter, when in doubt, graph it out. But just remember, graphing only works most of the time. I'm talking about 98% of the time. There's always a few exceptions to the rule, which I'll show you an example of an exception to this graphing strategy toward the end of this video, so watch out for that. So if you're going to solve by graphing, which is totally fine, we first enter your equation into the y equals menu on our calculator. Once you have it, obviously we're going to look at the graph, and when we see the graph, we're going to look for the points of intersection, where the two sides, we're going to have y1 and y2, and we're looking for points of intersection. Once we find a point of intersection, that's where the answer to our equation is going to live, so we want to find that. So here's an easy example. I want to start off by first solving this one by hand. Okay, because it's a pretty easy example, and then we're going to go back and solve it by graphing just to show you that method as well. So to start off, I'm going to say minus 4 each side. So I have 3x equals negative 11. Then I want to get x by itself, so I want to divide by 3. So x equals negative 11 thirds. Now you can either leave it as a fraction or just use your calculator to turn that into a decimal. So let's do that as well. So on my main screen, so negative 11 thirds. I get negative 3.67 if I round, which rounding is okay. Just remember that is a rounded answer, so it's not the exact answer, but it's pretty close. All right, so now I want to rewrite the entire problem just because I want you to be able to see it better. And I'm going to solve by graphing. Again, graphing works about 98% of the time. So, when in doubt, try graphing. So, whatever is on the left side, I don't care how messy it is always going to go y1. Likewise, whatever's on the right side of your equal sign, I don't care how messy it is, it's going to go y2. Okay? So, what I'm going to do now is put this in my calculator. I'm going to hit the y equals menu and then type my stuff in. So, I've got 3x plus 4 in y1, and then negative 7 in y2. As soon as you have that entered in correctly, hit graph. Always start off a new graph by hitting zoom 6. And I can very easily see that there's a point of intersection here. That point of intersection represents graphically the solution to this equation. So now I'm going to use a calculator to figure out what that point of intersection is. So to do that, I'm going to hit second calc, option 5 for intersection. First curve, I'm just going to hit enter. Second curve, I'm just going to hit enter. And then I'm going to move this flashing cursor using my left and right arrow keys into position. Once that flashing cursor is in position, then and only then you need to hit enter. So I get my point of intersection was x equals negative 3.67. I also get a y coordinate, but I'm not asking about y in this problem, so I don't need it. So all I'm focused on is the x. So x equals negative 3.67. Again, I rounded. So either way, we can see that doing it by hand or by graphing, either way works. Obviously, though, if you do by graphing, it saves you a lot of time and a lot of written work. So graphing is a pretty nice strategy. Okay, let's do another example. Remember, just like when we solved equations algebraically in earlier classes, you sometimes had multiple solutions. Same thing when we graph. Sometimes we're going to have multiple points of intersection, and that means that there's going to be multiple answers to our equation. So let's do this example. Only doing this one by graphing, so whatever's on the left goes in y1, whatever's on the right goes in y2. So using my calculator, I'm going to clear out my ink and go to y equals. Now, absolute value, to get there you just hit math, go to the number menu, and the very first option is ABS for absolute value. So 3x plus 4, be sure you close those parentheses. And then in y2, I'll put my positive 7. Graph it. Every time you do a new picture, always hit zoom 6. That's just a good practice to be in. And you can then very clearly see that this equation has 2 points of intersection when we graph it. So that means there's going to be 2 answers. I need to find both of them. So I'm going to start my process. Second calc, option 5 for intersection. First curve, you just hit enter. Second curve, you just hit enter. And then guess. Again, I move my left and right arrow keys to move my cursor. I like to find the point of intersection on the left first. So once I'm there, I get x equals negative 3.67 if I round. And then I'm going to find the point of intersection on the right, so I need to do the process again. So second calc, option 5. First curve, enter. Second curve, just hit enter. Then guess. Use your right arrow key to move into position. And I get x equals 1. Now, it's very important to know that on that guess step, you use your left and right arrow keys to move your cursor into position. If you do not do that, your calculator will not give you the right answer. So you have to put your cursor in position as close as possible. Otherwise, the calculator is going to keep repeating answers that you've already found. And you don't want to do that. Okay, let's do another example. I got a pretty intimidating looking equation. This is called a trig equation or a trigonometry equation. Also, I see pi. So whenever you see pi, you need to be in radian mode. So I'm going to pull up my calculator. I want to hit the mode key and make sure I'm in radians since I see pi. That's for any equation you see pi, you want to be in radians. Now, sometimes we need to restrict the domain or the range. In this example, I'm just going to show you how to restrict the domain. Restricting the range or the y values is pretty much the same way. But you're going to know you need to do a restriction when you see an inequality. So here I'm restricting the x values. X values are essentially associated with the domain. Y values are essentially associated with the range. So I want my x values, I only care about the x values between 0 and 2 pi. So in my calculator, I need to take care of that before I do anything else. So I'm going to go to Window to take care of my restrictions. I want my x to be between 0 and 2 pi. So x min I'm going to change to 0. X max I'm going to change to 2 pi. Everything else I'm going to leave alone. Now I'm ready to start graphing. So I'm going to go, again, whatever is on the left, no matter how messy it is going to be in Y1. Whatever's on the right, no matter how messy it is, it's going to be in Y2. Okay? So let's start off with this. Now, our calculators will not type cosine squared of x. So instead what we're going to do in our calculator, and it's equivalent, the same thing, we're going to type cosine of x squared. That means the same thing as what we have here, plus sine of pi fourths squared, because our calculator won't put the square in front for whatever reason. It's just a weird programming thing. Okay, and make sure we got that typed in correctly, and we do. And then y2, we put our 1, and now we're ready to graph. We can see that there's a couple of points of intersection, so let's find what those are. So it looks like there might actually be 4 points of intersection, one here, one here, one here, and one here. Okay, so I want to say second calc, option 5, first curve enter, second curve you just hit enter, and guess. I'm going to go and move my cursor all the way to where I think the first point of intersection is. And I get 0.78, so x equals 0.78. Now I want to find the next point of intersection, so I need to repeat the process. Second calc, option 5, first curve enter, second curve enter, guess, move your cursor into position. And I get x equals 2.35. Again, I'm rounding, no big deal. And actually that should be 2.36 if I round correctly. Alright, let's find the next point of intersection. So second calc, option 5, first curve enter, second curve enter, guess. And I get 3.93. And then the last point of intersection, repeat the process. Second calc, option 5 for intersection. First curve, just hit enter. Second curve, just hit enter. Guess. Move your cursor into position. X equals 5.50 if you round. Okay. Now, I want to look at my interval. Obviously, all of these x values are bigger than 0, so that part's good. But I want to check out 2 pi. So in my calculator, I want to figure out what decimal 2 pi is. So I'm going to go to my main screen and just type in 2 pi. So that's 6.28. So essentially, if I round, obviously I want to type in 2 pi to be as exact as possible, but essentially if I round, I want my x values for my answers to be between 0 and 6.28, which all of these are. So these are all valid solutions. So this equation on this interval that I've restricted the domain on has 4 solutions. Obviously, if I expanded that interval, I might have more solutions. And if I didn't have any interval at all, since it's a trigonometry equation, I would have infinite solutions. So just watch out for that if you need to restrict the domain in this case, or to range if you were restricting the y value. So keep that in mind. Okay, and like I said at the beginning of this video, graphing is a great option. It works about 98% of the time. However, sometimes the calculator will not work. You won't see any points of intersection, no matter how much you play with zoom. In that case, what's happening is it's called no real solutions. However, complex solutions do exist. Here's an example of one. Again, I'm going to start off my graphing. Y1 on the left, Y2 on the right. Clear everything out and type it in. So x squared plus 4, negative 6 on the right. Okay, I'm going to graph, and I want to hit zoom 6. Every time I do a new picture, I'm going to hit zoom 6. So here's my x squared piece. Here's negative 6. Obviously, no matter how much I play with the zoom, these two graphs are never ever going to intersect. So there's no points of intersection. Anytime you have no points of intersection, that means there's no real solution. But there is, yes, complex solutions. And complex solution always come in pairs. Okay, which we'll see an example of later. So anytime there's no points of intersection, the calculator cannot help you anymore. So to find the complex solutions, which always come in pairs, you're going to have to solve this equation by hand. We're not going to address that in this video, so you're going to have to wait to see how to do that, find those complex solutions in videos later on in this chapter. So be on the lookout for that. But again, if you're intimidated by the algebra, graphing works the majority of the time, but it is important to know how to do the algebra at least a little bit. That way, if you run into a situation like this example, where there's no real solutions, you can still find the complex solutions. Let me know if you need help.